Earlier in this video series, we talked about how your layout dictates what you need. What I'd like to do is take a few minutes with our mock layout here and show you exactly what your layout, what exactly you would need for your railroad if you were to integrate command control into a layout such as this. So right now, size really isn't an issue. We could say it's 16 by 8 feet for argument's sake. But what I'd like to do is identify what I have here on the railroad plan, and then let's walk through what would be required to operate this particular layout. So what we have is the red line represents one main line that runs around the perimeter of the layout. We have a passing siding down here on the bottom for the red line. The blue line represents a second main line that runs around the perimeter. Green is a third main line that runs on the innermost perimeter of the layout. I've color-coded these red, blue, and green to identify the different power districts, if you will, meaning that we can put a train on the red line, let it run unattended, train on the blue line, allow it to run unattended, and a train on the green line and allow it to run unattended without the three trains colliding into one another or creating a derailment. The orange section here in the middle is more of a yard area. We have a lead track to a turntable with 3 sidings on it, another spur track off to the side with some switches, 2 sidings. We've color-coded this orange because this would be a 4th power district. Basically what you'd be able to do is operate, if you were operating conventionally, you would be able to operate a conventional locomotive on the red track, the blue track, the green track, and the orange track simultaneously. It's important to note that where we have changes in color, such as from the green track to the orange track, we would have the center rail gapped so that our power from the green track stopped at those gaps in the center rail, and this became our next power block, this whole area here in orange. We would also take and gap the center rail on our sidings so that we can turn our sidings on and off independently. This way, we park a locomotive on there, we can shut that siding off. If we park a locomotive on our lead track, we can shut that off, which means that we'd have to gap the rail here as well. So let's take a look at our switches and determine what we would need for switch control, assuming that all of the switches on this railroad are remote control. It makes no difference if they're fast track, Lionel O or O27, Gargraves, MTH, Ross Custom switches, Atlas O, makes no difference. But we will assume that these are all remote switches. So let's get a count to determine what we need for controllers. For instance, on our passing siding here on the bottom, we have 2 switches where we enter the siding. It's highly unlikely that this switch will be thrown when this switch is not. So we can assume that these 2 switches will count for 1. So we'll number those number 1. Our crossing siding from track 1 to track 2 and from track 1 to track 2 meet the same criteria. This switch will never be thrown when that switch is not. So this will become switch 2 and this will become switch 2. Same thing here. We have switch 3 and 3. Same thing again, 4 and 5. Another passing siding, so 6. Another crossover, this would be 7. This crossover here would be 8. This single switch going into our siding would be 9. The switch into another siding would be 10. Into another siding would be 11. Into our staging track would be 12. Our Y coming out to both switches would be 13. This switch would be 14. And finally this switch would be 15. Now we've got one more switch left in the equation, and that would be the crossover switch that goes from track 3 through a diamond over to track 1. And that would ultimately be switch 16. Again, on switch 7, 16, 8, 2, 5, 4, 3, 1, and 6, the likeliness of us throwing this switch without throwing that switch is pretty slim. So we can run 2 switch machines off of one device, or one address for a device. So now we have to look back and say we have a total of 16 switches on our railroad. 16 switches. How do we control those? Well, if you're using slow motion switch machines like a Tortoise or a DZ1000, you're going to need to go with an ASC. Each ASC will control 4 switches. You have a total of 16. You're going to need 4 ASCs to control your switches wirelessly through the remote using command or legacy. If you are using Lionel Fast Track or Lionel O gauge or O27, Atlas O switches, MTH real tracks or scale tracks, you can use an SC2 to control them. Each SC2 will control up to 6 switches. So in this arrangement, you would need 3 SC2s, all programmed to control 6 switches. You'll have the functionality to control 18 total, but you're only going to use 16 of the outputs. Let's move on. Let's talk about track 4, track 3, track 2, and track 1. Earlier on in the video presentation, we talked about having to make the decision between wanting to operate conventional and command engines simultaneously, or only operating command engines. So let's take a look at how we would best apply our products to running this railroad. Let's assume that we want to run simply command and command only. I would recommend using 4 powerhouse direct lock-ons. Direct lock-ons or powerhouse lock-ons, same difference. Using 4 of those in conjunction with 4 180 watt powerhouses. Those 180 watt powerhouse and direct lock-on combos would provide the 10 amps, 180 watt power that we need for all 3 tracks. Our direct lock-on would provide our circuit protection in the event that we had a short circuit. We don't damage the trains and we don't damage the transformer because the powerhouse lock-on does the work for us. Let's assume we want to be able to operate conventionally. It's your choice here. What are you going to run? Are you running mostly products that have DC can motors, so they have very low current draw? If that's the case, you can go with a device such as a powerhouse and a power master, or a power master with another manufacturer's transformer, or even a post-war Lionel transformer. Using a power master, you would still need 4 of them. 1 for track 1, 2, 3, and 4. That would give you the ability to increase and decrease your voltage manually through the remote. Increase and decrease voltage, whistle and bell for your DC offsets. And you've got independent control of 4 loops. If you want to run command engines, simply turn the throttle all the way up to 18 volts and you're running in command. If you're running something that has AC pull-more motors, primarily more than DC can motors, and you're going to have a much higher amperage draw on your track, you're going to want to go with something like a TPC 300 or TPC 400, so that you can have between 15 and 20 amps of available power for each loop of track. Now, the likelihood of you running multiple engines on the gold track or the orange track here at any given time is pretty slim. So you can use a TPC 300 in conjunction with a 135 watt powerhouse. That's 7.5 amps to power your sidings and the staging tracks on your turntable, the lead track going into your turntable. 7.5 amps is sufficient. For your other 3 main lines, I would recommend the TPC 400 with at least 180 watt powerhouse. That would give you 10 amps of current for all 3 of the outside loops. Now, if you find after operating the layout that 10 amps just isn't enough, you've already got a TPC 400. add another 180 watt powerhouse to each one of those TPC 400s for a total combined amperage of 20 amps per loop of track. You've got room to grow, and the likelihood of you exceeding 20 amps of current on each track is pretty slim. Now, we need to talk about how we control this passing siding, the lead track, and our two sidings in our yard. Again, we're going to use a power block, which means that we're going to gap the center rail so that we have an electrically isolated center rail here on the first siding, on the second siding. We may even want to do it here so we have a third siding that can be turned on and off. We're going to go ahead and label those A, B, and C. So we have A, B, C, D, E, and finally F. 1, 2, 3, 4, 5, 6. We're going to want to be able to turn off our locomotive tracks. So we'll go G, H, and I. The reason we want to turn these off is, God forbid we have a locomotive sitting there, turntable isn't lined up, we turn the throttle and it has the same ID number, it's either going to hit the bumper or it's going to dive into the turntable pit and most likely create damage and a short. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 sidings or tracks that we want to turn on and off. To do that, we can use an ASC, which is capable of turning on and off 8 sidings. We have a total of, what do we say, 9, 2, 4, 6, 8, 9 sidings. We can use 2 ASCs, or we could use 3 block power controllers to turn our sidings on and off. The choice is really yours. I would not recommend using an SC2 or an AMC or a accessory voltage controller for turning these sidings on and off. Bad suggestion. Stick with the ASC or stick with the block power controller. This way, using the handheld remote, you're able to turn each one of these sidings on and off. This way you put a command controlled passenger train into siding F and you want to shut the power down. You can address accessory or switch, or you would address accessory 7, aux 2, shut that power off. Now you don't have a passenger car train sitting there with incandescent lamps eating up available amperage. When you're ready to run that train, you put another train here in this block, shut it down. Again, you can block that. We can make that J. You can shut this block off or this block off. You're going to have 3 ASCs anyhow, 2 ASCs. You've got another 7 available slots to use. So we can create one here, and we can create one here. So really we've got F, we've got J, and K, no problem. This way we just gap our center rails on the red line. We're able to turn off all of the blocks through a cab 1 or legacy remote. We're able to turn all our sidings on and off. We're able to control our track, able to control all of our switches. Accessories such as crossbucks, or, well, let's talk about crossbucks. If we have some crossbucks on our railroad, say right over here, we've got a set of crossing crossbucks that flash when the train comes by. We go back to our video we did on using an insulated outside rail, and we electrically isolate our outside rail on all 3 main lines, tying that activation rail together to our accessories. We run our accessories on a fixed 14-volt supply. Whenever a train enters that insulated block area, our crossbucks turn on. Train leaves, crossbucks turn off. Same thing on our main lines for the use of a 153E, C, or IR. If you have a single or double signal bridge and you want to be able to control the red and green lamp, you would use either the 153E with the insulated rail using the same methodology here, where all three rails perhaps would be insulated, depending upon what the signal is controlling, one track or multiple tracks. Or if the signal bridge is controlling only the red track, we can do an insulated outside rail here to trigger the 153E to turn our signal from green to red and back from red to green. Do the same with the blue track, the green track. If we have gate men, any animated accessory or trackside accessory, we've explained all this in a video. Insulated outside rail or 153C, E, or IR. Perfect device for controlling any of those devices on your main line. We also need to talk about accessory voltage here. We're going to have some type of accessories on this layout, be it cross bucks or signal bridges or gate men or animated accessories or street lamps, illuminated buildings, whatever. This is a pretty big layout, 8 by 16. The chances of us having a requirement of 8 to 10 to 15 amps to run this is pretty good. So for accessory voltage, you want to make sure that you run a fixed voltage, typically at about 14 volts. So you can choose a CW80 if you have those laying around, a PowerMax 40 watt, PowerMax 30 watt, any MW, KW, RW post-war transformers that you have, they're all perfect for accessory power supply. If you don't have any transformers laying around and you need to select something, we recommend the accessory voltage controller. Using the AVC in conjunction with 235 watt powerhouses will give you a combined total of 15 amps to run your accessories. 15 amps, more than enough at a fixed 14 volts to operate your cross bucks, your signal bridges, illuminated buildings, street lamps, whatever you have. So let's recap real quick. On a layout such as this, we're going to have a total of 3 SC2s if we're running twin coil switch machines, or 4 ASCs if we're running slow motion switch machines or DZ1000s. If we're using low current drawing locomotives, such as those with DC can motors, we're probably going to run PowerMaster and Powerhouse combination, or PowerMaster and Powerhouse combination, or PowerMaster and conventional transformers such as post-war ZW, Z4000, MRC dual power, whatever you have. But you want to make sure that you've got at least 7.5 to 10, all the way up to 20 amps available for your track power. If you're running AC motors, that you have a much larger amperage requirement or current requirement, TPC 300 or 400 in conjunction with two 135s or two 180 watt powerhouses. For our sidings, for all of our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, our 11 sidings that we want to be able to turn on and off, or our power districts, power blocks we want to turn on and off, those 11, we can use 2 ASCs programmed to accessory, or we can run 4 block power controllers. Your choice. The accessory voltage controller in conjunction with 235 watt powerhouses can give us 15 amps of accessory power, more than enough. We've talked about how to trigger our single animation trackside accessories and our double animation trackside accessories such as signal bridges with the 153 family of devices. The only thing we have left on this railroad to talk about is your turntable. And your turntable is really based on your preference. You can set this turntable up to run off command control using a command upgrade available from Electric Railroad Company, which will allow you to address this turntable as an engine and control it. You can use an accessory motor controller and address it as an accessory. You can use an accessory switch controller to address it as an accessory to turn it on and off. Aside from that, your railroad's covered. You will need a TMCC 1 command base or a legacy number 990 command set. That's what's going to generate the command signal that's going to run all of these various devices such as your ASC, your SC2, your block power controller, your accessory voltage controller, and ultimately run your command controlled locomotives. So that sums up how we would wire this railroad. If you have questions about how to wire your railroad, feel free to contact us at Lionel Customer Service at the number at the bottom of the screen. We'll be happy to assist in helping you make the right product selections for your specific needs. Thank you.